Hey everyone, I will now be introducing to you guys the derivatives of the three other trigonometry identities. However, these three identities are only for the H2 math students and not for the O-level A math students nor for the AH1 math students. And these three are actually cosecant x, cotangent x, or actually secant x first, and cotangent x. In the MS26, you'll only be able to see for the derivatives for cosecant and secant, but not for cotangent. Although it's actually good to actually memorize these three because you don't really want to waste time flipping the MS26. And that's actually a pretty nice way to actually remember. Alright. So in the MS26, you'll be able to see this derivative. So this will be minus cosecant x, cotangent x. And dy dx for secant x would be secant x, tangent x, right? There's a way to prove this. You can just rewrite secant x as 1 over cosine x and use your power rule. And, it's pretty easy. But actually the main point I want to drive across is, if we were to actually look at the derivatives of the original function, you notice a certain trend, right? And it's actually very likened to your identity, your cosine square x plus sine square x equals to 1, and then you then have tangent square x plus 1 equals to secant square x, and you also have 1 plus cotangent square x equals to cosecant square x. You notice that in the earlier video we shown that sine x and cosine x, they are about the same for the derivatives, right? So y equals sine x derivative is cosine x. And now you notice that for cosecant x, we have cotangent x, right? So as you can see from here, as for secant x, we also have tangent x over here. And that's why it's easier to remember this way, because if you look at the integration, where you talk about integration next time around, you notice it's the same thing as well. You see secant x and tangent x together, you see cosecant x and cotangent x together. For cotangent x, well, I would show it through the power rule because it's not found in the MS26, but it's also fairly easier to remember. So 1 over tangent x, so power rule, I will get, first I bring down the power to the front, which is minus 1. Reduce the power by 1, becomes minus 1, become minus 2. Differentiate tangent x, we give him back secant square x. Secant square x over tangent square x, well, you'll give me back cosecant square x. Okay? And that's the derivative of cotangent x. And you notice cotangent x, cosecant, right? And if you compare with tangent x, right, you notice the derivative is a square as well. Same thing for cotangent x is also a square. So it's quite easy to remember, right? Cotangent x, you get cosecant square because it's related, so I get cotangent square x as well because it's tangent. Tangent x is secant square as well because we notice over here, tangent square is same as secant, is related to secant square, and therefore if you have tangent, we get back a square. Whereas for secant and cosecant, well, it just go by the identity as well. And yeah, there we have it, the derivative of cosecant, secant, and cotangent. Obviously, I can bring in the composite functions. So we have, like, let's say cosecant, let's say x squared. It's the same, right? It was exactly the same. The difference is that now we have to differentiate the inside, which is x squared, and then we put the rest of the identities inside. Alright, so I don't think I'll need to show you the general form because I think from here you guys will be intellectual enough to actually find the general form for here. So yeah, there we have it, the derivatives of cosecant x, secant x, and cotangent x for the H2 math students.